Can scatterplots visualize high-dimensional Python data? Have you ever wondered how to visualize complex data with many features? Scatterplots are a popular choice for showing relationships between 2 or 3 variables. But what happens when you have high-dimensional data, which means data with many features? This is where things get a bit tricky. Human perception is limited to 3 dimensions, so directly plotting all dimensions in a standard scatter plot is not possible. To tackle this challenge, we can use dimensionality reduction techniques. These methods help transform high-dimensional data into 2 or 3 dimensions while keeping important patterns intact. This allows us to create scatter plots that reveal meaningful information. One effective approach is the scatter plot matrix, also known as a pair plot. This method creates a grid of scatter plots where each subplot shows the relationship between a pair of features. For example, if you have for features, you will see a for-by for grid of scatter plots. Each plot compares one feature against another. This is great for exploring pairwise relationships, but it can get overwhelming with many features. Python libraries like Matplotlib Express and Seaborn make it easy to generate these scatter plot matrices. Another popular technique is principal component analysis, often referred to as PCA. This method identifies the directions, known as principal components, that capture the most variance in your data. By projecting your high-dimensional data onto the top 2 or 3 principal components, you can create a scatter plot that shows the main patterns. While PCA preserves the overall structure, it may overlook complex nonlinear relationships. For more intricate data, T-distributed stochastic neighbor embedding, commonly called t-SNE, is a nonlinear technique that focuses on preserving local relationships. This means that points that are close together in high-dimensional space remain as close in the low-dimensional plot. t-SNE is particularly effective for visualizing clusters or groups in complex datasets. After applying t-SNE to reduce dimensions to 2, you can create a scatter plot that displays data points colored by labels or clusters. However, keep in mind that t-SNE can be computationally intensive and sensitive to its parameters. There are also other techniques and visualizations to consider. Parallel coordinate plots allow you to visualize multiple dimensions by drawing lines across parallel axes for each feature. Additionally, specialized Python toolboxes like hypertools combine dimensionality reduction and visualization, allowing for interactive exploration of high-dimensional data. In practical terms, you can use libraries such as scikit-learn for implementing PCA and t-SNE. For creating scatterplots and scatterplot matrices, libraries like Matplotlib, Seaborn, or Matplotlib are great choices. For instance, after reducing your data to 2 dimensions with PCA or t-SNE, you can plot the results with a scatter plot. Color the points by class or cluster to reveal the underlying structure. In summary, while standard scatter plots cannot directly visualize high-dimensional data, combining scatter plots with dimensionality reduction techniques allows for effective visualization of complex datasets in Python. This approach helps reveal patterns and relationships that are essential for data analysis and interpretation.